Okay, now we're going to sit there and assume the following is a true conditional statement. If an angle's measure is between 90 and 180 degrees, then it's an obtuse angle. Well, that is a true conditional statement because it's true if it's between 90 and 180 degrees, and it's true that it would be an obtuse angle. Now, we're going to call this our original conditional. We're going to change it up using different forms of making conditionals. The first one we have to identify is what the hypothesis is. So the first thing we're going to do is realize this first one's the hypothesis. It's after the if, so we're going to call it P. And then we have our conclusion. And we're going to call it Q. Now we're going to manipulate this one conditional statement 4 different ways. And the first one is the converse. The converse is a conditional statement formed by switching our hypothesis conditional. But notice what changes here. The Q and the P switch spots. Notice the words if and then don't move. So what would be the converse of our first statement up above would be the following. If an angle is an obtuse angle, then its measure is between 90 and 180 degrees. Or I'm going to use the words here. I was going to abbreviate, but that doesn't work quite as well. But notice one thing here. We keep a proper noun in the hypothesis, and then we can use our pronouns at the end. I still capitalize, and I use my correct punctuation here. But that's a converse. Now you should ask, is it a valid statement or not? If an angle is an obtuse angle, then its measure is between 90 and 180 degrees. That is a true statement. So I always want to check to see if it's true or not. Well, the next form that we have of a conditional statement is called the inverse. And we need to kind of introduce a new symbol. This symbol right here is a negation symbol. It means make the opposite, okay? And it represents the word not. So we're going to make something not what it was. Now, to find an inverse of a conditional statement, you formed by negating both the hypothesis and conclusion. And notice I still put the arrow then. The P and the Q's don't switch spot this time, but I negate them. So we go through something more like this. If an angle's measure is not between 90 and 180 degrees, then it is not an obtuse angle. So you have to be very careful when you do this. Notice we negated it, that we put the words not in. Let's say the word not was there in the first place, well then you take it out. Then we have what's called the contrapositive. The contrapositive is the combo package. It brings the converse and the inverse together. Notice the symbols here. The Q and the P are switched, and I've also got the 2 negation symbols. So in this case, we have a conditional statement formed by negating both the hypothesis and conclusion of a conditional statement, then switching them. So basically, you negate and flip-flop. So the contrapositive is a conditional statement formed by negating both the hypothesis and conclusion of a conditional statement, then switching them. So here, basically, a good way of thinking of it is do the inverse and then switch the inverse around. So it'd be the following. If angle is not an obtuse angle, then it doesn't measure between 90 and 180 degrees. I gotta love this because it's simple. We flip-flopped it. Now remember, we're still always going back to this first phrase. If the angle's measure is between 90 and 180 degrees, then it's an obtuse angle. So it's really kind of cool. Now, the last but not least we have is what's a biconditional. A biconditional is no longer going to be a conditional statement. It's going to be an if and only if statement. And notice the arrows go both ways. So with this one, we have to have a couple stipulations. It's not always possible. An if and only if statement is what a biconditional is, formed if a conditional statement and its converse are both true. So notice up above, I on purpose went there and said, all right, the original statement's true and the converse is true, which that means I can write a biconditional. And this cool part, it doesn't matter if you put the conclusion or the hypothesis first, as long as you combine them. So here's one of the best ones I like. An angle is an obtuse angle (90 and 180 degrees. Now, understand I can't always write a biconditional. This time I could because both of them are true. So you have to make sure they're both true. Understand not all true conditionals have true converses. Not all true converses have true conditional statements that are original. But you need to understand that all definitions can be written as biconditionals, like a midpoint or parallel lines. Like for instance, lines are parallel if and only if they are coplanar and never intersect. And another thing we need to remember is not all conditionals are written in contingent forms. So I kind of want to show you some examples of a conditional that are the same, and then we'll end here. If we zoom in here, notice the first sentence right here. If a number is even, then it has a factor. It's really what we can think of as a conditional statement. But notice all of these, and by the way, P will always represent the hypothesis, C the conclusion. Notice they're all the same thing. A number has a factor if it is even. Well, this now becomes my hypothesis. A number is even implies it has a factor. Implies replaces the word then. A number is even only if it has a factor. Only if replaces the word then, but it's still a conditional statement. And this is the one that drives me crazy, but it still makes sense. It says all even numbers are numbers that have factors. All, and what's after the all shows my hypothesis, and my conclusion is everything after R. This is also at the bottom of your notes. All of these phrases right here I showed you, but I want to let you have a visual representation of this also. So hopefully this helps you with your homework. Make sure you do every problem because it's going to be on the quiz.